Alright, so part 3 of our polar graphs. This one is going to focus more on using what we did in that previous lesson on solving multi-angle equations to help us out with things like a maximum, a minimum. We're going to talk about where this graph is increasing or decreasing or positive and negative, things like that. So this will be probably the more challenging of the group of lessons that we run into, but here we go. So looking at this, we got 5 sine 3 theta, so that's the graph that we're working with. We're given a restricted domain of 0 to pi. So independent, dependent on this, just keep in mind whenever you talk about r theta, we look at the coordinate like this, but this is the independent. This is what we plug into, and this is the dependent. This is the result, right, that we get out of it. What's the shape made by the graph? So we know this would be a rose. This is in the form of a sine n theta, if you remember that one. So we know this guy would be a rose. So max value on this. So when we start talking about maximums and minimums, remember with this, this graph, as I look at that a value, that's like the end of the rose petal on that one. So I know it's going to bounce between 5 and negative 5 on this. So when we look at this equation, let me write it down here, 5 sine 3 theta. I know this guy is going to bounce between positive 5 and negative 5 as far as like max and min values are concerned. Well, because of this, this is what determines those. So if we divide everything by 5, we end up with this equation. And so that's really all we need to deal with as far as solving for like a maximum and a minimum. So we're looking at this side for the maximum, and we're looking at this side for the minimum. So for this part of it, if I just want to look at the max values, well, let's just solve the right side of the equation. So if we said the sine of 3 theta is less than or equal to 1, here's what we just did in that previous lesson. So how do we solve for 3 theta? So if we do our inverse sine of 1 is 3 theta. So we'd say, okay, well, the sine of what angle is 1? We know that would occur up at pi over 2. So pi over 2, and then we throw on the infinite plus 2n pi equals 3 theta. And then we divide everything by 3, and we bring that up here. So that becomes pi over 6 plus 2/3 and pi. Alright, so we get this. So if there was no restriction on this, that would be our unrestricted solution set, but we got to go according to this. So I need to find all of the solutions in there from 0 to pi. So this is where we start plugging in values for n. So if we plug in a 0 for this guy, well, if that becomes a 0, all I would have is pi over 6. So there's our first max value. If I plug in a 1 for this, so 1/6 plus 2/3, so that would be 5/6. And if I keep going, I plug in a 2 or a 3, my values are too big. They go beyond this. They go beyond pi. I'm not allowed to do that. So that's it. So these are going to represent the two max values. The min values, we're just going to solve this side of the equation. So if we were to say that negative 1 less than or equal to our sine of 3 theta. So now we're solving for the negative 1 instead of the positive 1. So just like we did the one up above, but we would start by just saying, well, let's do the inverse so we can isolate 3 theta. So we know that 3 theta is equal to the inverse sine of negative 1. So where does sine give us negative 1? So that would occur at 3 pi over 2. So our 3 theta is equal to this guy, which is 3 pi over 2. This is where we throw on our plus 2n pi. And if I divide everything by 3, I got my solution set. Let's see, that just becomes pi over 2 plus 2/3 n pi. So we get that look right there. So if we start plugging in our values on this, we'll start plugging in like 0, 1, and 2. So if I plug in a 0, all I would have is pi over 2. If we plug in a 1, that's going to be too big. So if I plug in a 1, I'm getting something bigger than this, and so I got to stop. So that's it. So I got two maximums, I got a minimum. So when we look at this graph here in a second, that's where we're going to see those guys as maximums and minimums. So I was going to start graphing these guys, but let's peek at this first, and then we'll throw some points on the graph. So let's set this guy equal to 0. We got maximums, we got minimums, and zeros. So if I take my function up at the top, my 5 sine 3 theta, and if we set that equal to 0, if you divide by 5, it's still going to be 0, right? So the 5 can go away. Let's do the inverse sine of 0 is 3 theta. So the sine of what angle is 0? So that would occur at 0, then pi, then 2 pi, then 3 pi, then 4 pi. So that's where we get all those. So in other words, n pi would represent all of those solutions. So our 3 theta is equal to n pi. So if we divide everything by 3, so here's our solution set. We got n times pi thirds. If I can squeeze it in there. So again, that would be our infinite set, but we have a restricted domain, so let's come up with our values for that. So if I plug in a 0, that would just be 0. If I plug in a 1, I would get pi thirds. If I plug in a 2, I get 2 pi thirds. And if I plug in a 3, I get 3 pi over 3, which is just pi. And I got to stop there because that's where my domain runs out. So, but it does say or equal to pi, so I can keep that last one. He's okay. So I wanted you guys to take a look at this graph in light of those values that we just came up with. So remember, we knew this was a rose. We know based on this that there are 3 petals. The length of each petal is 5. So let's just start looking at that graph. Remember, there's a little formula for how we figure out where the sine roses start. Cosines always start on the axis, so that's easy. But when it comes to the sine functions, we have a little formula. We'll do it off to the side here. Remember, our starting value is at pi over 2n, right? That tells you where the sine rose begins. So in this case, here's our n value is 3. So at pi over 6, if I plug my 3 in there, that's going to be the starting point of this graph. So if we go out to 1, 2, 3, 4, 5, so there's our first petal. If we know that there's 3 petals to this, remember they're spread out evenly. So if I did 360 divided by 3, that means 120. So every 120, or you could say every 2/3, I get the next petal. So starting from this guy, if I add 2/3, now I'm over to this guy. So 1, 2, 3, 4, 5. Remember, this does have pi over 2 axis symmetry, so I know these mirror each other, so that helps me to find my next point. If I go another 2/3, I'm down here. 1, 2, 3, 4, 5. Right, so you can see those are perfectly separated. So if you take a look at our max and min values and our zeros, how did this occur? So for this guy, remember, sine graphs start at the origin, right? Wait for the bell to stop. So at 0, it started at 0. So that's like the first point on this graph, right? But then as I approach pi over 6, I'm hitting a maximum. And we said on this one, my max was 5. So as I approach pi over 6, my values approach 5. But then what happens after that? After I approach the 5 over 6, now I'm approaching my next 0. So now it's going back to 0 as I approach pi thirds. And then what happens after that? So after that, after you approach pi over third, now you're approaching your minimum. So you can see down here at my next pedal, right, there's the pi over 2, but I have a minimum. So it was like I went negative and then pi over 2. So that's why it's down here, right? So that's my minimum. So that's where it goes next. Well, after you hit a minimum, it always goes back to 0. So now I'm back to 0 for this one. And then after 0, now I hit my next max. So as I approach 5 pi over 6, I'm hitting my next max. And then ultimately, as I approach pi, I'm going back to 0. So I wanted you to see how the max, the mins, and the zeros give you the key points on this graph. But we also want to start learning the order in which those appear. Remember, with a sine graph, just think of your normal sine curve. It starts at 0, and then it goes up to the max, back to 0, minimum, back to 0, max, back to 0, and that pattern would continue. So that's what this guy looks like so far. So let's connect those thoughts into this table. I already laid a lot of this out for us. We can just kind of fill it in. But keep in mind the order that this went in. We said this started at 0, right? So it starts at 0. That's a 0 radius, right? And then it went to the max of 5 as we approached pi over 6. And then it goes back to 0. So now my radius is 0. And then it goes to the minimum of negative 5. And then from there it goes back to 0. And then it goes to a max of 5. And then it goes back to 0. So this is what the radius did, right? And again, that's just your basic sine graph, right? It starts in the middle. It goes up, back to 0, goes down, back to 0, up, back to 0. And that pattern would continue forever, right? So, and then these are just the key locations where that occurred. So that's going to be important to notice as well. So a couple questions we're going to be asked on this. Is it positive or negative? Is it increasing or decreasing? You're going to be asked if, as you approach like pi over 6, are you getting farther away from the origin, or are you getting closer to the origin? Questions like that. So that's where hopefully some of this will help you as we start putting these things together. So my numbers on this side were positive as I was approaching pi over 6, right? I was going from 0 to 5. So my numbers are positive. And I'm going from 0 to 5. My numbers are getting bigger, so this is an increase. And then the next portion from here to here, so as I approach pi thirds, my graph is doing this. So now it's decreasing. It's still positive. I'm going from 5 to 0, so it's still positive numbers. But now they are decreasing. All right, so we get this guy here. And then we'll just keep going on the pattern here. So remember what it did after that. From this angle to this angle, we start approaching negative 5. Right? So now we're looking at negative numbers. And is that an increase or a decrease? As I go from 0 to negative 5, my numbers are becoming more and more negative, which is smaller and smaller and smaller. Right? So that would still be a decrease. And then from there, as I go from negative 5 back to 0, so now I'm increasing. They're still negative. I'm still in the negative from negative 5 to 0, but they are increasing at least. Notice on that my distance to the origin is decreasing. That's another question we run into with these is your relationship to the origin increasing or decreasing? So as you do something like this, my distance from the origin is increasing. I'm going farther and farther away from it. But from pi over 6 to pi over 3, my distance to the origin is increasing. Right? Or sorry, they usually say from the origin. So my distance from the origin is decreasing as I go like this. Finish this off. So from 0 to 5, what are we doing now? We're positive numbers again from 0 to 5, and they are increasing from 0 to 5. And then last portion of this, so that was this guy. Now we're going back to 0. So from 5 to 0, my numbers are still positive, but they're getting smaller. From 5 to 0, they are decreasing. And again, you're going to run into questions like, from here to here, is your distance from the origin increasing or decreasing? right? Well, if I'm going from here to here, my distance from the origin is decreasing. I'm getting closer and closer to it. All right, so jump down to this guy right here. Try to keep that table in front of you while we're answering this question. So how can we use a table to identify angles for the max and min curve? Well, anytime I go from an increase to a decrease, right, that would have to happen at a max. My numbers are going up, 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 and then down, down, down. So that would always happen at a max. So if you're increase to decrease, that's a maximum. If you are decrease to increase, that would occur at a minimum. So we got that part. For the next part, so this is whenever it's increasing, the distance between the graph and the origin, so here's that type of question I was referring to, is increasing. So whenever the radius is increasing, it said. Well, let's see, let's find a case that would potentially disprove that. So if I am increasing in value, like if I go from -5 to 0, that's an increase in value, right? My numbers are getting bigger from -5 to 0, but my distance from the origin is shrinking. I'm getting closer and closer to it, so it's a decrease for that part. So you can fill that in your own words. Average rate of change, so super important. We do have to be able to do rate of change with this stuff. Remember, rate of change is slope. We're just doing y minus y over x minus x. So we're doing our y values, so f of pi over 6 minus f of 0, just because of what they said here. So it's like my y values over x minus x. So it looks something like that. And then we just simplify that. So what did we have at pi over 6? Right, so remember at pi over 6, if you go back to our graph, that's one of our maximums. Right, we had a max of 5. Let me bring this up. We had a max of 5 at pi over 6. At 0, we were at the origin. We were at 0. And pi over 6 minus 0 is just pi over 6. So if we clean that up, 5 over pi over 6, let's multiply by the reciprocal. So it becomes 30 over pi. That would be our average rate of change. So that's the average rate of change from 0 to pi over 6. All right, let me flip the page. So you can jump to this page. I'm going to show you what's already been filled in here, and you can feel free to pause and jot down the important key points. But let me just sort of talk you through them so you know what you're looking at for this. All right, so we have our extrema. We got our maxes and mins that we took a look at. We looked at increasing and decreasing intervals. And we talked about distance from the origin. So I want to make sure we say that correctly. It's from the origin, not to the origin. So notice as we put some of what we did on that table together over here. So when my r was increasing, my radius, and it was positive, then my distance from the origin was increasing. I'm going to kind of go back and forth because I want you to see that. This is sort of important. So when my r was increasing and my r was positive. So that was something like this. So if it was positive and increasing, like 0 to 5, right? If I'm doing this, then I'm getting farther and farther away from the origin. So my distance from the origin is increasing. But what about in a case like this where I'm increasing but my r is negative? Well, let's find one of those cases. So I'm increasing but my radius is negative. So every number between here and here is negative. So what's happening on that? If I go from -5 to 0, from -5 to 0, my distance from the origin is decreasing. I'm getting closer and closer to it. So that table really helps explain this little graphic that you see right here. So that's a kind of a great little summary of that table, so you can kind of see the rest of that. And then of course average rate of change is just slope. It's the change in radius over the change in angle. right? So it's like y minus y over x minus x. So we just plug into that little formula, and that's what we got. So a couple check for understanding questions that we're going to talk about when we go through this in class. A lot of what you're doing on this, something that's really helped me answer some of the questions that come up with some of the AP reviews and things like that. You can definitely make a graph. That's a great tool, and you should understand the graph. That's a great tool. But you can also make tables, and you can plug in points. That's a great tool as well. The table that we did on the first page is really helpful in understanding where we're increasing and decreasing and positive and negative and things like that. Super helpful. So keep that in mind. There's a lot of approaches you can take to this. So plugging in table values is a great approach, and definitely something you can do. So I already filled this in to save a little time. We just took turns plugging in the numbers into our function here. So those guys went in for theta, and then the result right here is the radius, right? And these were the results that we got out of that. And so definitely then helps to answer questions like this. So where is it increasing? So you can see where it goes from, let's see, where's our increases here? So from -6, that was the lowest it got. So from -6, it's building, 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 getting bigger and bigger all the way to 2 pi. That's what we're seeing on that. So where's it decreasing? Well, this was the highest it got, and this was going down, 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 all the way to pi. And then it started going back up again. So that was our decreasing interval. For max and min values, let me slide this down. So we saw that we had a max right here. That was our biggest number. It occurred at 0 and 2 pi. We had our minimum of -6. That was our lowest value that occurred at pi. So we had that. Here's some of the, I like this question because this helps you to start seeing some of the little tricky type of questions that we can run into with some of this AP content. They can ask some pretty tricky questions in here. So they posed the question on this about these two intervals. So we're going from 0 to pi, and we're going from pi thirds to 2/3. And they're saying which one is basically faster, which one is bigger, which one has the bigger rate of change. So we're just going back to our y minus y over x minus x to get these. And so that's what we did here. Remember, these are the radius. That's your change in radius. So when you look at 0 and pi, look at the radii that go with those. Right? We had -6 and 2 if you look back up at the table. And so that's our radius minus radius over angle minus angle. Pi minus 0. Right? And so that's that one. If you do the same thing for this, change in radius over change in angle, you get this. Right? So which one would be the bigger value, basically, is what they were asking. And so you see the one on the right is the larger value. They're going to have the faster rate of change. Okay. And then the last question that we'll look at today, so they give us a specific interval, and they want to know about increasing and decreasing. And we plugged in a couple values right here to see what those radii are. So again, making a table and a table of values really helps for questions like this one and those max and mins and things like that. So plugging in values for the angle and looking at table values, that's a good approach too. So we'll kind of use all those tools available to us. And that is it for that one.